All right. So Tovio and I met and discussed kind of plans moving forward for things. Obviously, we did a schedule change. You're probably expecting Tovio today. We talked, and they wanted me to cover dictionaries and the other data structures before they continue with the material that they're teaching. So that's what we're going to do. We're going to cover between today and Monday, we're going to cover the remaining 3 major data structures in Python. So I'm going to kind of go over an overview, talk about how everything's going to fit together, and we'll just get right into it. Let me get my screen share up. Okay, cool. Also, do go ahead and post an emoji in the thread if you haven't done so already. I notice there's more people in the meeting than have posted yet. Go ahead and do that. All right, so overview. Let's do our overview. And I'll be quick about this. I know this can seem like one of those things that's like a little monotonous, or I fear that it could be, it could feel a little monotonous to do this. But I think it's good to just remember when I was learning, I would learn information and I'd be like, well, where does this, how does this all piece together? So to me, I think it can be useful to see how everything fits together, what categories everything goes in. That way, okay, I'm learning this thing, I'm learning about this thing, that doesn't preclude or exclude or overlap with some other thing. It's in line with this, or it overlaps this, so you kind of, how everything fits together that way. Okay, so we've got our data types. We've got abstractions, control flow, and iteration. For our data types, that's where we're going to be focusing all our attention for the next couple of days. We have covered our number types, int and float. We've covered, let's do bool, because that's technically a numeric type. Kind of goes with ints and floats, but feels different, right? Has a pretty different role in practice. Int, float, bool, we've got strings. We've got none. And we've talked about lists. So the 3 remaining major built-in types in Python are, I'm going to put an asterisk next to the ones we're going to cover, tuples, sets, and dictionaries. Or dict is, I'm going to use the, so the, oops. The reason I'm typing these this way, by the way, the reason I'm typing str instead of string is str or set or dict. Some of these are shorthand, names for the type, but they are actually the formal built-in type specifier. So just so you know, that's why I'm shortening these names or typing them in this way. It's useful to know the type specifiers because you need them. You need to do type checking occasionally, and you need to know if the type of this is a string, you're checking if type variable equals str, for example. So stir. So yeah, that's worth remembering in that way. The reason I always put this space here, by the way, too, I'm careful about the way I lay these out. You've heard me say this before, but these types are the immutable types, and these are my immutable types. So, you know, the one thing I hope that gives you an idea of sort of how I evaluate the importance and the role of mutability, right? Even in laying this information out, I make a distinction between, okay, what are my immutable types and what are my mutable types? And I group those together. You know, there's not really, I could group these in various different ways. You know, I could do strings and tuples are collections, but they're immutable collections. I could group them down here, but I think the more important distinction is what types are immutable versus what types are mutable. And I hope that that gives you some picture of kind of how to think about this. It's important to have that, to like take note of that. Anytime you're learning a new type, is it mutable? Do I need to think about this as mutable, or do I need to think about this as immutable? So, yeah. So we have sets and dictionaries, which are our mutable types remaining, and we have tuples. Tuples, understanding tuples, I'll just touch on this really quickly. Tuples are very similar to lists. We could say that they are immutable lists. They have a funny name, might make you think they have like a pair of items. I think there's like some etymology that kind of relates to that. It's a related word to couple, where a couple of items is two, and I think tuple means an unknown number of items. But so that name can be a little misleading, but it is essentially just a list that doesn't have the capacity to change its size or its elements. We can do concatenations on it, which are an immutable transform, and there's some kind of things that we can do with immutable features that can kind of give us some similar characteristics to mutability, but they are essentially lists that don't have mutable methods. If you understand lists, you have the knowledge. If you feel comfortable working with lists, you already have the knowledge to work with tuples. We'll just kind of define clearly what is and isn't mutability and go from there. Sets are really kind of the furthest outlier. There is a sense that when you look at a set, when you print out a set, that it kind of looks like a list. I think people think, oh, well, they're kind of like lists. And it can be a little deceiving. We'll talk about some ways that they're different, and some ways that they're useful, and some ways that they're not useful. Sets are like lists and strings and tuples store elements in a ordered collection. I've been sure to kind of like drive this idea of ordering, and it might seem kind of weird because, like, you know, of course, if I put A in the list and then I put B and then I put C and I print the list out, it's intuitive that, of course, the list would hold A, B, and C in that order. That's not a given in a data structure. It's an intuitive thing that is easy to assume, but should only be assumed. Well, it shouldn't be assumed. It should be understood based on the data type. So sets, and this is actually true of dictionaries too. Sets and dictionaries do not retain an order. Dictionaries have a mechanism for storing values and retrieving them. Sets do not. So when we store elements in a set, we can't access those elements and like pull out a single element. We can cast a set to another type that we could pull out a given element from if we wanted to do that. So they're not really useful for like storing information that you plan to retrieve later. So they're kind of, I just want to say that now because of that, they're sort of the furthest outlier type. They're different in a number of regards. It looks like we've got a couple questions here. What are you indicating by the asterisks? Oh, sorry. The asterisks are the types that we're going to cover between today and Monday. So these are the types we haven't covered yet. Yeah. Sets are, sorry. Somebody's asking, sets are ordered? Sets are unordered. If I may have misspoke and said that they are ordered, or I may have said that, I think I said that in kind of a way that, like I interrupted myself mid-sentence and that sounded like I was saying something I didn't mean to say. So yes, to be very clear about this, sets and dictionaries are unordered. Strings, tuples, and lists are ordered. When you hear ordered, you can infer in every case, in almost any programming language, but definitely in Python, in the types that we've talked about, ordered is synonymous with having a numbered index. That is technically two separate ideas, having a numbered index that starts at 0 and having an order, right? It's conceivable that you could have one without, well, it's conceivable that you could have order without indices, but it's not conceivable that you could have indices without order. So when we say something is ordered, you can infer in every case that that type uses a zero-based index to retrieve elements or slice subtypes of that. Okay, cool. I won't go over these because abstractions are variables and functions. Control flow is if else, and kind of understanding Boolean operations. Iteration involves understanding essentially for loops and while loops. There's more to iteration than that. There are other iteration types. We talked about map briefly, which is solves a subset of problems that for loops solve. And that can be kind of a neat tool sometimes. But essentially for our purposes, you can get done what you need to get done with for loops and while loops. At least you can get through all our material. It's oriented around using those. Okay, cool. So that's that. And just to be clear, we're focusing on the types noted with asterisks there. I feel like I should just throw this into Slack just so people can reference it. At least you have the type identifiers if you want those. We also have a comment here, sets are random. Yeah, that's a good way to think about it. I'm kind of, I think that is actually the correct, or the language that's used. I'm kind of a stickler about being, I'm like kind of fastidious about using random and arbitrary in their correct domains. But I believe the Python documentation does refer to them as random, and I think that's a common way of thinking about them. So that is correct. I think about, if you're a stickler like me for the difference between random and arbitrary, I think about sets as having the order in which they are processed or dealt with is arbitrary. So as an interesting side note, something that's random is reliably inconsistent. It's a system that you can rely on to be unpredictable. So you could think about that, in the context of a randomness generator or something in computer science or in programming, right? It's something that could be designed to give back an unpredictable result, right? Whereas arbitrary is unpredictable, but the reason or the way it may be unpredictable isn't reliable. So randomness is reliably unpredictable, and arbitrariness is unreliably unpredictable. So there are times where we'll get into this when we get into sets. You'll see what I mean, and dictionaries to some extent. There are times where you're going to make a set or a dictionary, and I'm going to say this is not an ordered type, and you go make a set, and in your editor, and you'll print it off, and you'll print it off again, and it'll print off in the same order every single time, and it'll look like there's an order to it, and then you'll assume, okay, well, I guess there's always an order to it. But there are certain contexts, some of which are in your control, some of which are not in your control, that will govern the order, that will give us a different order. So even if at times it appears as if they're ordered, it's an illusion, so don't rely on it. So the way I like to think about them is that sets, the ordering of sets is arbitrary, but evidently the way that it's written about is that they're random. Ordered. Let me catch up here. Ordered, which are processed reliably. Okay, cool. All right, let's actually get into something. So I'm going to spend most of the time on dictionaries. We're going to kind of we probably will not get to sets and tuples today. Full disclosure, I know I talked a little bit about tuples and sets. Dictionaries are the type with what I would consider like the most kind of moving parts. There's a bit going on with dictionaries. They're not what I would say, I wouldn't describe them as like horribly complicated or difficult, but there's more to them than the other types. And for that, they're, like if you're comfortable with just kind of picking these up and kind of, methodically kind of learning these, you might have to spend a little more time with dictionaries than you're used to. So, and that's okay. That's usual. That's normal. So dictionaries are, well, let's just get into this. Dictionaries contain key value pairs. So I said that they are unordered. So key value pairs in a mutable, unordered collection. So they're unordered. Given that they don't have an order that we can rely on, they can't be indexed, right? Because the the third element in a dictionary, one time isn't the third element the next time. And even if you print them out or run through them in a for loop, you'll see something resembling an order, but it's just because, the way we process that information, we as humans process that information, comes out in a linear analog because we need some way to represent that information. So it appears ordered, even though in the machine, there's no semblance of order. So having a numbered index you could, but it would give back an arbitrary value every time, so it wouldn't really be useful. You'd have an arbitrariness generator, not even a randomness generator. So instead of having, remember I talked about they don't have an index, but they do have a mechanism for, they have a way of, when you store an item in there, that you can retrieve it, that you can pull it out again. So instead of having indices that correspond with the, the literal positional location relative to the start and end in order, instead of having indices that are automatically inferred, they have keys that are explicitly given essentially by us. So instead of having indices corresponding with their elements, they have keys corresponding with their values. We'll often talk about a key value pair. Okay. Something to note about the keys must be an immutable type. We can use any of the immutable types as a key. We cannot use a mutable type as a key, and we'll talk about that. And unique, which means, so they must be immutable and unique. So I can't have the same key twice. The key is our mechanism for retrieving a given value located at that key. So if I said, if I had the key poodle in there twice, what should you get, the first or the second one? But there is no first or second because it's not ordered, so it's not really sensible. So we can't rely on dictionaries having duplicate elements. So dictionaries are declared using curly brackets or the dict constructor function like this. I would just recommend using the curly brackets. By recommend, I mean just use curly brackets. The dict constructor function is useful for casting something to a dictionary. We'll talk about that as well. And then here's an example of the syntax. So let's just jump into this and start talking about how to make dictionaries. Okay. So let's do something like this. So if I wanted to declare an empty dictionary, I'll just start there. Maybe I wanted to do a dictionary accumulator. Pretty straightforward. I'm just going to use curly brackets like this to just denote that this is a dictionary. If I want to have elements in my dictionary, let's say, what do I want to do? I always do this analogy, this like car analogy. So let's say I'll make a dictionary that represents information about my car. So I'll say Toyota. Oh, excuse me. Make. Okay. So Toyota. Let's say model. Oh my gosh. Model, we'll say Highlander. And we'll say year 2011. Oops. And then maybe I could do yeah, we'll just start there. So make, model, and year. So notice, now I'm laying this out on each line like this, which is what I prefer to do, because there can be a bit to them, to a dictionary, and when it's all on one line, it can get a little mashed together. You can see it's a little hard to see where one pair ends and the other begins. Quickly. It's not that hard to discern in this case, but dictionaries can get a little crammed if they're on a single line. So I like to break them out like this, and this is fairly typical way that you'll see dictionaries made. There's sort of a number of ways that these tend to be formatted, but this is the way I like to do it. Okay, so what are we looking at here? So we've got this pattern of, in this case, we've got the string, we've got a string and then a colon and then some element. So we've got an element and then a colon and then another element and then a comma. And that's the pattern. So element, colon, element, comma. So what's happening here is each pair separated by a colon is a key value pair. And it's key followed by value. So the elements on the left, remember the keys can be any immutable type. It is most typical that a key is a string. Most of the time, you'll find that it makes sense to use a key, a string as your key, or much of the time. Sometimes you'll also use integers or floats. It's not that common to use tuples. You could use Boolean, you could use none, but there's only 2 Boolean values, and there's only one none value. So that could be a little weird. I could see a potential application for that. You can actually you kind of make your own control flow patterns that way, which are neat, but I don't know about the practicality of them. But it's kind of neat that you can do that. So you don't tend to see Booleans or none. So most often I'd say you see either a string or an int or a float as your keys. And the reason you see a lot of strings as keys is, I mean, look, we can name a specific field according to whatever we want it to give us. So it would make sense that if I'm storing information about my car here, that I would store Toyota under a field called make, under a key called make, right? So the value of the make would be under a key called make. So let's just look at this. Let's print this out. Okay, cool. So you can see it's given this back to me in the order I placed it in. And I ran it a few times. Hopefully you saw me run it a few times. It's running. I'm gonna run it again. And I'm getting this make model year, make model year, make model year. So remember this, I'm trying to demonstrate here that you will see dictionaries sometimes retain an order. And don't be fooled by it. It's an illusion. Quite often it is the case that the order in which Python chooses to process a dictionary or print it out will reflect the order that elements were put into the dictionary. If you know about how your computer's memory works, how things are assigned and allocated to in memory in your computer's RAM, you can think about how a stack structure would allocate this information. Well, Python starts at the top of a document and goes down. Well, it's going to allocate make before it allocates model, before it allocates year. So it's very likely that even though a dictionary is a heap allocated type, that internally there's some stacked system within the elements, right? So it's very likely that that information is stored in bytes in your memory that are physically contiguous with each other. They're literally next door, and it just reads it left to right, as it were. A lot of cases where it's read right to left, but we can think about it as being read left to right, just in whichever order it's stored. So it's very likely that Python looks at this and says, well, what's the way that I can optimize this the easiest? And it discerns that it's probably the way that it was, the order in which it was inputted. So it's likely that it will appear ordered a lot, but don't be fooled. Okay, cool. I want to make sure we kind of check off each of these. So key value pairs. Dictionaries contain key value pairs in a mutable, unordered collection. I want to open up for questions at this point. I know this, we're just kind of jumping into a new thing, and there's probably a bit, but does anybody have a question? Oh, okay, and we do have a couple here, so follow up with an example. I think you're asking, will I follow up with examples of unreliable and predictable versus unpredictable before Monday lectures? We're going to be playing around with dictionaries a bunch. You'll see it. And then another one, can the last dictionary key value entry end with a comma? Yes. I forgot to mention that. And it's common that you'll see this. It's what I like to do. The reason I like to do it is, if for whatever reason I wanted to add another one, I can just do a line duplicate, and it's just easy. It's easy to add another key value pair like this and do like something like that. Okay. I'm not seeing any other questions. So just a quick recap. Dictionaries contain key value pairs. You can think about the keys as being, rather than a list, if this was, let's just do this. If this was a list, let's do car D, and let's call this Carl. Let's just call it Carl. No, we'll call it Carl. Car list. So let's make a list. And you might think, well, how are you going to store it as a list? It's not going to be as good. It's not going to be in one-to-one analog, right? Because I have to. I don't have keys, right? I have indices, right? So it doesn't. A list isn't as well suited for storing this information. I could do a list of sometimes you will see this. Could do a list of tuples or a list of lists, and kind of model that information that way. That's kind of like a dictionary, but it's kind of something different also. So rather than having an index, we have a key, and that key, unlike the index is automatically generated based on its position. The key is given either literally, often literally, or deterministically by us. And when I say deterministically, I mean like, maybe we have a function that generates the keys based on a data set. So that's not uncommon as well, to have that key determined, to have keys determined while while your program is running. So they don't always have to be explicitly stated string literals or integer literals. They can be determined by other things. But one way or the other, we either wrote those keys in literally, or we wrote logic that figures out what the key should be. You know, we as the programmers determined what those keys are somehow. And then the value is associated with those. So if this were, maybe I should just keep this, maybe I should just keep this list up here. Yeah, let's actually just keep this list. Let me do this. I'll do this. Okay. Because we know how lists work. Okay, so in a list, if I wanted to retrieve a certain element, let's say I want to retrieve Highlander here. Well, Highlander is at 0, 1, it's at index 1. So if I print car L sub 1, I'm gonna get Highlander. We got a couple questions. Dependencies. String. Find keys and item. So you could run 2 sources to combine keys and items. 2. I'm not sure if that's a question for me. I'm sorry, I'm not clear on what's being asked there. That's okay though. Yeah, if you want to, maybe it's obvious, but yeah, if you want to clarify, I'll be happy to take a question about it. Okay, so if I wanted to recover Highlander from this list, I could do car list sub 1. What would you imagine if I wanted to do the same thing? If I wanted to print out Highlander from the dictionary, let's say car D. I'll leave it to you. How can I modify this line to print out Highlander from the dictionary? Oh, maybe that's what's being asked. Are you saying if you had 2 lists, if you could assign the values of list 1 and the keys in list 2? There's a way to do that. We talked about the zip function. We can zip. It's a parallel lists thing, right? Parallel, when we talk about lists or types being in parallel, we talk about collections, or we'll just say lists, that have usually the same number of elements between them, and each element corresponds across their indices with the elements in another list. And you could definitely see that as a key value pair. There's a lot of cases where that works fine. Or CSV or data source. Yeah, there's ways of turning those into dictionaries. And we'll talk about that. It occurs to me to say that's a good thing to talk about, and it does. There are times when I've definitely done that. I remember asking similar questions, and I get a lot of similar questions. It might be less common. It occurs to me to just say, like, it might be less common and maybe less important than it might appear. But we will cover that. Cool. And we got an answer. I want to get maybe a couple more people chiming in here. I think that's good, actually. You can put in an answer if you want. So people are saying, okay, so the question on the table, just so we're extra clear about this, I wanted to just get a few answers in. Feel free to put one in. I don't mean to shut it down if you want to get an answer in there. But I wanted to make you think about this, right? So your keys are analogous to your indices. Your keys in a dictionary are very much analogous to your indices in a list. So if I want to get an element out of a list, I specify list sub index, wherever the index of the element that I want to see. If I want to get a value out of a dictionary, I specify the key. Okay. I'm embarrassed to admit this, but I do not know if this is how model is spelled or this. I'm just going with this, but just full disclosure, if I'm getting that wrong, this is a dyslexic moment. Both ways look equally valid to me. So this is one of those things where EL or LE, I never remember those details. So I feel like that's right, but anyways. So this is the syntax. This is how we can recover the same value. We just specify D sub key. One thing I want to clarify here as well, when I say sub, right, we'll talk about, you'll hear us talk about, and I will use this language as well. When we talk about lists, I'll say you'll index the list. You'll index the list at 7 or at 0 or whatever. So we'll talk about indexing. What the more formally correct way, everybody knows what that means. It's okay if you say that. It's one of those things where it's like it's technically incorrect, but the whole industry says it and we all know what it means and it's fine. The more correct way of saying that, though, is to say we're subscripting a list at a location. And the reason we think about it as subscripting is it's the same system for dictionaries. They're just not an index, right? So, we can't say dictionary indexed at model because the subscription system in a dictionary is not an index, it's a key, right? So in either case, it's subscripting. We use a indexed subscript for the ordered types, and we use a keyed subscript for dictionaries. So I know this can, right? This uses a system that's familiar from lists, but it's different because you're used to putting a number here, and now there's a string. So I want to be clear. Is there anybody that looks at this line 37 and is just like, what the heck is going on? Is there anybody that isn't getting that? Maybe put some kind of emoji. I don't know. What's an easy emoji to get? I don't know how comfortable people are with the emoji keyboard in there. Let's just do this. 1 or 2. 1 means you don't get it. 2 means you get it. Doesn't have to be a perfect understanding, but you're like, yeah, okay, I basically see what's going on there. Okay. I want to see 1s and 2s. If anybody's a 1 on this, it's important to me to know. We got a couple questions. How how do you prove syntactically whether or not the Highlander is in the dictionary is the same object as the Highlander in list? You could get its ID. Let's do this. I don't know if it will be the same object or not. I have no idea actually, because strings are they're an immutable type. A lot of times what happens with an immutable type is if you have two values that are the same, it'll just create one object and just reference it where appropriate. But I don't know if they're being stored in line or being stored off-site from both of these and being pointed at in some way, but let's see. They are the same object. That's pretty cool. So both of these Highlanders, so this is kind of funny, right? It looks like there's a string that says Highlander in this and a string that says Highlander in this, but there's actually only one string in my computer's memory that says Highlander. And both of these objects encompass it. It's kind of weird, right? You can do things that aren't really physically feasible with a computer. So this one object exists in two places. There's a lot of quotes in that. Okay. I'm seeing all twos. That's great. Okay. If you're one and you don't feel comfortable speaking up or putting yourself on the spot, you can DM me or whatever. But I do want to make sure that that this is landing because it's pretty central. We will move on for now. Okay. Key value pairs, mutable, unordered collection. Keys are immutable and unique. Let's cover the second line. Really, we just covered this first line here. Let's immutable and unique. Okay. I'm just going to copy and paste this. Okay. So the Highlander, somebody's asking, so the Highlander objects have the same ID. Yep. They have exactly the same ID. Yeah, that's, if you ever want to see if two objects in memory are like the same or different, I always use ID. If they have the same ID, they are the same object. It's like, I mean, you know, I always say it's like a VIN number on a car, you know. Two cars that have the same VIN number are the same. They're not two cars, they're one car. Unless for some reason the same VIN number got put on two cars, which I don't know. Maybe that's possible. So the same Highlander, you typed out the whole entire ID. That's dedication. Yeah, I just look at the last few numbers, by the way. But yeah, okay. So saying so this the same Highlander object has the same ID. Oh, sorry, that's the same point. Oh, sorry about that. Okay. Let's see then. Let's talk about keys being immutable and unique. I don't think we need the list for this one. Oops. Apologies here. I might have something going on with my audio. Give me 1 second. Okay, sorry about that. We're good. Somebody's asking, what about the ID of the two Toyota objects? I'm gonna move on and talk about keys being immutable and unique, but I want to pose that question to you. How would you? I'll come back to that if you haven't figured it out by the time I get through this. ask me again and I'll show you. But yeah, how would you determine if those two Toyotas are the same? You think about that. It's an interesting one. Okay, cool. So keys must be immutable and unique. Okay, so that's what we have here. No problems. I'm obeying the rules of the dictionary. But let's say for some reason I have a Honda. I don't know why I think this is funny, but I'm actually going to do this. A Toyota. We'll do model twice, and we'll do Civic. Okay, which is not a Toyota car. So let's say I duplicate this key model. Just before I run it, that's always a good thing to do. Anytime you're like poking around in your code, you're doing something to find out what's the behavior here. Before you run it, you don't have to before you run it, think about it, but don't think about it necessarily as like, okay, I better anticipate this correctly. Just note whatever it is you assume. So what do you assume is going to happen here? I just said keys have to be unique. Unique means that there can only be one of them. Is it going to let me do this? Is it going to throw an error? Is my CPU going to light on fire? Are the Zoom servers going to go down again? Really, anything could happen. Okay, and remember, we're just noting our intuition, so yeah. My intuition is that it's going to overwrite it. Okay, we got a couple people. Somebody's intuition is to test it. That is that is the correct intuition. Just run the code. My intuition is to run the code to tell me what my intuition should be. That's not a bad way to approach it. Got a few people voting for error. Somebody's saying model value will be overwritten with Civic. Changing my answer to Zoom servers going down. Yes, correct. Zoom servers will go down if you try to do this. No, I'm just kidding. Okay. So we're mostly seeing people saying that their intuition tells them that if I have two of the same key, right, the value is different. We're getting two dominant answers. One group of people saying it's going to give an error, and other group is saying it's going to be overwritten. This is not about getting this right. This is about what did you assume. It's just important as you're going through this. Notice that you do make assumptions. Note what those assumptions are. Test it out and adjust accordingly, right? It's a very scientific approach. It's not like did you get it right or not? It's not about that. It's about we make assumptions, that's fine, work with it. Okay, so this overwrites it. And notice it's going to overwrite it with the last one declared, right? So in my code, order does matter. The code, this document is executed from top to bottom. It's executed from the top of the document to the bottom of the document. So it says, okay, I'm the Python interpreter. Okay, I see a dictionary. I'm going to make a dictionary. This dictionary has a key called make with a value called Toyota. It has a key called model with the value Highlander. Okay, so those two things are established at this point. It's canon. We've got make and model, Toyota, and Highlander. And then I see, as I, being the Python interpreter, anthropomorphizing a lot here, and I see the another key called model, and the value is Civic. So I'm going to say, okay, since I can only have one, I'm going to make that key called model equal to, or have the value of Civic. And then I'm going to go to year 2011. So it overwrites it. It overwrites it with the one that's further down the document, or whichever command was executed most recently. Cool. Supposed to have two clear overwrites. Okay. But how is it possible if it's unordered? So that's a good question. And yeah, I'm hoping what I just said was kind of an attempt to answer that. So the Python interpreter starts at the top of a document, and it goes from the top, reading each line left to right, just like English is read. So top to bottom, lines are ordered top to bottom, and lines are read left to right. Top to bottom, left to right. So things that happen in the top of the document happen before things that happen further down. Events that happen further down are capable of overriding events that happened further up. So when this code is executed, right, there's an order to that execution, right? So line 42, when the Python interpreter parses this document and starts executing code, as of line 42, there's no dictionary in memory. As of line 43, there's a dictionary declared to be placed in memory. Once that dictionary is, the code to generate that dictionary is fully executed, and it's executed in order, that code is executed in order. You know, this is not a dictionary, really. What you see, you must see through the dictionary. This is not a dictionary. This is text in a text document that Python will understand and parse into storing what it calls a dictionary in your computer's memory. Once that dictionary is stored, it's an unordered immutable object. So hopefully that makes it clear. Does that help your question? Wait, what makes it stored again? Okay, so the interpreter, so you have the Python interpreter, which is a program that reads Python code and executes those commands accordingly. So it's a program that executes a program. So that's the interpreter. The interpreter starts at the top of the document and parses the document, executing line. There are several steps, and I'm being very reductive here, but you know, it reads the document, and at some point it goes line by line, top to bottom. So line 45 is executed before line 46. Line 46 happens to overwrite what we did on the prior line, right? So once this dictionary is stored in memory, it's not ordered. But this is not a dictionary. This is text in a document. This is just text, right? It's Python text. That text is executed in an order. So the program still obeys its order, still obeys its execution order, but once that object is, you know, has been parsed by and read by the interpreter and stored in memory, at that point it is unordered. We think about it as unordered. So the document has an order. Once the document reads this as a dictionary, it's like, okay, there's a dictionary in memory. It's not, you know, we know what's stored in it based on the order the document's written in. The dictionary is unordered once it's in memory. Hope maybe that's clear. Hopefully. I know it's a bit of a weird one. There's a lot of like what's ordered and what's unordered. Cool, good. Seems like we're good on that. Same as a variable, if you reassign a variable further down, no matter the distance between, it will get overwritten. That was a much better answer than the one I gave. Yes, I'm going to go with that one. I won't claim it. That's a great description. Yeah. Is it? Yeah, that's exactly it, right? You make a variable, and then you reassign the variable. Once the program is finished executing, the value of that variable at the end of the program is whatever you assigned it last. That's the same thing here. So the retrieval can be random versus creation of the dictionary object. The retrieval, yeah, okay, so yeah, so there's ways of looping through dictionaries. There's ways of, I mean, you can obviously print a dictionary off. In those cases, there's something that happens that seems like an order. But that's because the way we humans process information has this sort of linearity to it that has to be conveyed. So, but in the computer, that order isn't retained. Not always. And there are times when it will give us back an arbitrary ordering that we can't predict. There are times where there are times where it will be consistent, and there are times where it will be inconsistent. So just assume it's always going to be inconsistent. We'll be messing around with dictionaries a lot, and you'll see it coming out of order as well. We'll be getting to that. For now, and I mean ultimately too, for now and ultimately, it's kind of a suspension of disbelief whether or not you're experiencing it as in order or out of order. The safe assumption is that the order won't be retained, so you write your code accordingly. But yeah, we'll be getting into that. Okay. Dictionaries are declared using curly brackets. Okay. Accessing and updating key value pair types. We've got a bit to get through here. I want to have some kind of break. Let's have a little bit of a shorter break. Let's just reconvene at let's do 14 minutes after the hour. That'll be a full 5 minutes actually. Okay. I'm going to step away and refill my water. I'll be right back. We can open up for questions if anybody's got a question. I can take a couple over the break. Somebody wants to do that. Okay. Let's see. Cool. So accessing and updating key value pairs. I mentioned, so there's something I want to mention, and I mentioned this when we first talked about lists, CRUD. So anytime you're learning a new collection type, string, tuple, listic, set, think about create, read, update, delete. Create, read, update, delete is CRUD, C-R-U-D. This is an acronym from like working with databases that you hear a lot of in like building full stack applications. So yeah, it's used to describe, you'll often hear it in the context of like a CRUD app, like a create, read, update, delete app, which is just meant to describe a complete sort of usage of a database. If you can do CRUD, you can kind of work with a database, So you can kind of use this analogy to think about certain key operations with any collection of data. A database is like a big, giant, much more complicated dictionary. But there's a lot of, a database is kind of like a little tiny bite-size, or excuse me, a dictionary is kind of like a little tiny bite-size database. So, or any collection type is a very simplistic sort of database. So that's a very, that's reductive, but there's some analogy to be made there. So I think CRUD is a good place to start. It's not exhaustive. It won't tell you every piece of useful information, but it'll get you a lot of important information. So we talked about read, how to access a value with subscripting. Some of you might be wondering like, okay, well, this is the G to indexing, we can get one value at a time. Some of you might wonder, like, well, can we do a slice? Is there something analogous to a slice? And there's not. There's not like, give me from A to C or whatever. There's nothing like that. So there's no analogy to a slice. You can only do something analogous to an index. So let's talk about updating though. Let's just do this. So create, read, update, delete. So this is sort of create the whole thing. Let's do this. Actually, let's do like that. I'll just store make and model there. So we know how to create a dictionary. We know how to create elements in the dictionary, key value pairs. We can also add key value pairs in after the fact. You might think of a list. List has list.append. Hello. What we can't do. Let's do this. Let me show this with a list. Just show this with a list really quick. Okay. So I start an empty list. I append hello to it. Once hello is in there, once I have an element in there, I could say list sub 0. This is called item reassignment. List sub 0 equals foo. Let's print list again. Okay, so I changed that hello to foo. What I can't do is this. Hopefully you can see this list has only one element in it. Hopefully that's clear. So I can't reassign index 1 to bar. I can't do that because I get an index error. List assignment index out of range. Can't do that. So I can't assign to a novel index in a list. I can assign to a novel key in a dictionary, right? So I can say car d sub year. Notice year is not in here. There's no year. I'm not reassigning something, I'm assigning and creating a new thing, right? So this is my preferred way of creating a new key value pair in a dictionary. Car d sub year equals, let's just do 2011. And then let's just print out the whole dictionary here. Make Toyota model Highlander year 2011. Try the key model, print car. Okay, looks like there's a, I don't know if that's directed at me. Looks like there's a side conversation, that's fine. Okay. Cool, so I guess we should do a before and after on this too, just like we were doing with the lists. So if I have car dictionary, this is after I make the car dictionary. And then after I add year to it, big surprise, right? I can also mutate a value at a given key. So this is create. Let's do an update. And we'll say model equals, oops, civic, right? So I can reassign an existing key, and it's sort of the same thing. I'm just going through the questions here. Huh. Okay, cool. All right, so that's a create. We have a couple reads kind of tied up in here, right? So this is how I can read the whole dictionary. Obviously, we covered read with read. We covered read with the D sub key. Something like that, right? So notice there might be a pattern that you might notice where we can kind of apply CRUD to the entirety of the type. Like, how do we create the type in the first place? How do we read the whole thing? How do we update? I don't know about updating the whole thing, but like it's just kind of updating a variable, I guess. And then how do we delete the whole thing? Those are all valid questions. And then we could also ask, how do we create, read, update, delete specific entries, right? So that covers read, create, and update for specific entries. And then let's do one for delete. What I like to do is just do the del keyword, del, this. So if I say del car submodel, that's just going to delete, notice, make Toyota year 2011. It's going to delete model from the whole thing. I can also delete the whole entire dictionary like this. I mean, this doesn't just apply to dictionaries. This is how we haven't really talked about the del keyword. So del deletes something, it just removes it from memory. So I can delete this dictionary, and if I try to access it, I get the same error as I would if I try to access something that just doesn't exist. It says name car D is not defined. That's the same error as I would get if I tried to say just access a random variable name that doesn't exist. Foo is not defined. So del is a useful, simple, and useful tool for deleting kind of anything. Okay. How do we delete specific entries? Lines 89 through 91 show that. Oh, I see what's happening. Sorry. I know I'm missing something here, but so far it seems like dictionaries are less functional than lists. What makes dictionaries advantageous than, say, a list of lists in these examples? If you have a list of, let's say you have a list of lists and each list contains a key value pair. Like you could model this information like that. And sometimes you do, because maybe you want, I don't know, maybe you want immutable or mutable keys for some reason. That doesn't really make sense in a number of regards. The reason this is nice is if this were a list of lists and you knew the key, but you wanted to recover the value, you'd have to index into the specific entry, check the first index, make sure that that's the correct key that you're looking for, and then return the second, or index one, excuse me, return index one, which would be the analogy to the value. So there's like, you could write a function that would do that, that would like handle a specific data structure that you're building to emulate a dictionary. There are times when maybe you would want to do that, but I think the case here is that it makes a common set of problems. It makes a use case that is common enough easy. Just kind of gives you some easy tools for doing something that you want to do frequently enough that every time you want to do that thing, you don't necessarily want to write a whole custom data structure and custom functions to handle kind of basic operations of that data structure. Yeah. I would say another reason is that they can be really useful is that they can associate a set of unique information with a value for each of those unique points. So there's in other languages, dictionaries, or in other languages have a type called like an associative array, which is essentially a dictionary. It's the analogy to a dictionary where you're associating one set of information with a different set of information. And there's sort of that parallelization. So dictionaries are very useful. They have I think it's just safe to say they have a pretty different use case than lists. Their utility is often pretty different from lists. There's a lot of problems though that you can sort of, it makes sense to solve with a list or a dictionary. So there's potentially a lot of overlap. But in most of those cases, you end up kind of conceiving of things differently enough that you could argue that they're just different problems at that point. How do we delete? Okay. You can only access a value through a list and not the other way around. So with a dictionary, you can only access, so here's the thing. If you know the key, you can access the value at that key. If you know the value, it doesn't work the other way. It's a one-way. There's an association between each key and its value, but it's a one-way street in any case. And that's actually kind of what's useful about it. Because you can if you make that assumption, you can make other assumptions, which are, that leads you to this kind of easy subscription syntax, where you can say, just give me the value at this location. Well, it's not an indexed location, it's a location that I gave a name to. So if your data wouldn't be modeled well with indexed elements, it might be modeled well with named elements, right? So if it makes more sense to name each location, then, or give some other special meaning to each location, a key makes more sense than an index in that case. You're welcome. Maybe if you had a huge dictionary of people and their ages, you want to find a specific person's age, you could easily find that with ages sub person's name without worrying about the order of that dictionary. Yeah, that's not a bad analogy. Another one is, okay, so let's say here's a good one. We could actually build this out too, might be kind of fun. You're parsing a document, and just like a text document, we covered text.split or string.split. So let's say you take in like a book's worth of text. You clean it up and take out any unmeaningful punctuation or whatever. You're analyzing the text, and you want to like analyze a distribution of like what words occur and with what frequency those words occur, right? So this is a problem that I really like to do with students. Oops. Because it's I think I'll just show it. I've been kind of debating whether I should show this, because I like to do this, work through this problem with people, but I don't think it's, like if I show it now, if one of you and I end up meeting in the future, I think we could totally do this problem again, and it's still kind of worth working through a second time. Okay. So let's say I have some text. Here's my text, and I want to do something where like I produce a dictionary that has the structure of each word in the text. Now I can't have duplicates, but that's kind of useful. It's useful that I can't have duplicates because I don't want duplicates. I just want to see, what words occur and how many times they occurred. So an integer representing the word's frequency. So this would be a word frequency dictionary. So let's do this. Let's say we'll print word frequency D. If I write a function, I don't do this as much with other types, but if I write a function that returns a dictionary, or if it returns a list, if I at any point think this is returning something and the thing that it's returning is kind of complicated, if I have to do kind of like, if I get the slightest inkling of feeling like that type is complicated, I start sort of trying to lean towards being really explicit about that type. So usually we're using dictionaries to model data that's at least a little complicated, right? This has a schema to it. And this is something that I'll do a lot when I'm writing a function that returns a dictionary. I'm constructing this dictionary and it has to have this very specific structure. I want strings as keys, which I'm kind of noting here. This is just my own shorthand. And my own shorthand on this kind of looks different every time, but it's semi-formal. But it makes sense to me as long as I know what this is, But I recommend this, when you're building out a dictionary dynamically, which is something you're going to do a lot. It's useful to be very explicit about what you want to end up with. So I like to draw out a little schema like this. Schema like schematic, right? Just a little something that gives me an idea of its form. This is not specific, it's general, and that's what's useful about it. It tells me I have strings, which represent the words, and then an integer representing the frequency. Okay, so I've got my word frequency dictionary here. We'll say def, frequency D. We'll take in, text, and we'll D equals empty dictionary, return D. Okay. So I have this whole thing kind of stubbed out, ready to go. And it's returning the empty dictionary. We're all plugged in and ready to start solving this problem. So I can say for word in, I'll leave this one to you. Who remembers how I can iterate through the words? How can I complete this line 102? Somebody's suggesting that we clean the text. Yeah, and that's not a bad idea. We're going to leave it dirty for now. But yeah. So I'm seeing a few answers. I'm not quite seeing some that are close. I'm being very pedantic about this though. If I were the Python interpreter, none of the solutions I see so far would complete the would give me the word. Remember, if we iterate through the text directly, a string directly, we get each character. Aha, there's one. There's a couple. Oh, and somebody corrected. Yeah, okay, cool. Yeah, so if I want to iterate through, and this is a very, very common thing to do, you know, it's usually more useful to iterate through text as each word, right? The word is the sort of the smallest meaningful unit of information to us, right? I'm not probably as a human analyzing text, I'm probably not as interested in what characters are being used. So iterating through text character-wise, it's something that you do occasionally, but it isn't, it's sort of not as useful, right? It's much more useful probably to be able to iterate through the words, because the words literally have meaning to us, right? They literally convey meaning that is their job, right? So because of that, Python makes this very easy since it's such a common thing to do. For word in text dot split. Okay. I saw somebody say we could split on spaces. We could do that. If we don't split on anything, it will split on spaces, new lines, and tabs. It's the only case where split will split on multiple things. It's kind of a weird one, but this will split on spaces, new lines, and tabs, which are, if you think about it, those are the delimiters. Those are the characters that delimit the beginning and end of words. Okay, so let's go to another one. Okay, so I could say if the word is not, if word not in, so what I want to say is if the word is not a key in the dictionary, so what I'm going to say, I'm going to check for membership in keys. I'm going to say if word not in d.keys. For those of you who have worked a little ahead, you might notice that I don't need d.keys. I always like to put in d.keys because it's explicit. If I want to check membership for keys, I can just check the dictionary directly. This does not check membership for keys and values, or keys or values. It only checks membership amongst the keys, as written right now. I kind of don't like that it does that. I think if I were writing Python, I'd have made it do, I'd have enforced this. It's a little more verbose, but it's errors on the side of being explicit. So that's just my opinion, though. So if the word is not in, if it's not a member of the keys, I'm going to check the membership of the keys there. Then I want to add it. I'll say d sub word equals 0. And then I also want to increment. Now that I know that word is there, I will increment that value by 1. That's why I started it at 0, because I'm incrementing it immediately afterwards. Another way you could think about this is, well, I want to count each word, so I'll say d sub word plus gets 1. But there is no, since I have a plus equals, that recompiles as this, right? Which means this has to exist somewhere first. I can't do a plus equals to something that doesn't yet exist, because plus equals what? What was the initial starting place of this? There's no, if you think about it, you can say, well, it should start at 0. Should it? Should that be the assumption? Why wouldn't it start with an empty string or an empty list? Just because you're saying it's a number doesn't mean that it's clear to Python that it should be a number, or what number it should be, right? So there's actually this by itself may seem like it should work, but if you think about it, it doesn't make sense for this to make an assumption about what the prior value should be. You want to be explicit about that. You're going to say, okay, well, the prior value, if it doesn't exist, is going to be 0 now. So we'll initialize everything with 0, and then we'll add 1 to it. If the word does exist in the dictionary, then it's going to, since we can't have duplicates, and this is a reason not having duplicates is useful, right? If I encounter the same word again, well, I'm going to access that same location. If it was capable of like adding in duplicates, then none of this logic would work. And if you think about it, that's true with the indices of lists as well. You can't have two indices in a list that are the same. And if you could, it would kind of take the utility out of having an index in the first place. It wouldn't be meaningful. It wouldn't be useful. So same with keys, right? You don't have 2 spots in the list that are both index 7. You can't have 2 keys in the dictionary that are both think, you know. So if I run this, oops, if I run this, I get this word frequency dictionary. So you can see each key corresponds with the number of times that word appeared in the list, or excuse me, in the original string. So actually, why don't we do this? Let's print this out in a better way. We'll talk about how to iterate through a dictionary. So let's say I want to iterate through this dictionary, and I want to be able to print out the key and the value. The key, the value. I'm naming these in an intentionally slightly verbose and silly way to make it clear that like these are not special keywords. I'm just like I can call these whatever I want, because it's a for loop and that's what you get to do, right? And this does match the pattern. So if I want to iterate through both the keys and the values in a dictionary, I can say for key value in dictionary, this function returns the dictionary I want to iterate through. In the dictionary dot items. So the dot items method is a really useful method. When you want to iterate through a dictionary, you usually want to iterate through dot items. So this will return a generator that, an iterator that gives you each key value pair that it encounters. Maybe in order, maybe not. Cool. So we look at this. Whose woods these are, et cetera, et cetera, et cetera. So hopefully that's clear. So you see we have some differences here. We have sleep comma and sleep period, right? So we could take a cleaning step to this string, and that's actually why I keep this a second version of this with the punctuation removed. We'll just assume we took a cleaning step. I won't write out that logic because it's kind of a whole different thing, right? You know, so now things are showing up more, right? So we'll assume if we cleaned it that we'd get a more accurate signal. And we could do things, we could like dot lower everything and clean this up further, but cool. Hopefully that's clear. What, you know, like this is something a dictionary can do that we could do this with a list, but it would kind of suck a little, you know? We could do a list of 2-piece lists, but it'd be more complicated and it'd be a little weird and a little rough around the edges, unless we did a bunch of additional work to clean it up, in which case we kind of it would make most sense to just make a data type that was suited to that task, and that's already been done for us with a dictionary. So what's the frequency for the words the, and yeah, so those are going to get different entries in here in the way that this is written. We could clean it like this, though. You could do dot lower, and then, yeah. So again, there's a whole, we could dive into like, filtering out words and cleaning this text more deeply, but yeah. Okay, cool. Moving forward. So we covered a bit with that one. Some useful methods. So I just covered items and keys, actually. So this is something, this is a pretty, to me, I think this was a pretty central thing in understanding how to work with dictionaries, right? We know there's keys and values. So we have these three methods. Let's just grab an example dictionary real quick. Okay. So we have these three methods: items, keys, and values. You might guess what they do. Whoops. I'll cast these as lists so that we can kind of see them in a more familiar context. Oops, I don't want to do this. Oh, actually, that is interesting. I didn't mean to do this top one, but let's look at what happens when we cast a dictionary, just a regular old dictionary, to a list. So here's the original dictionary. If I cast that to a list, notice it's a list of the keys. I don't get the values. It doesn't include the values at all. It just casts it as the keys. Probably not the behavior you expected, right? And we didn't do the like, what do you expect here? But I know I look at that and I don't need to know what I expected. I didn't expect that. So I don't know, maybe you did expect that, but either way, that's the behavior. So if we cast items or keys or values, if we cast these as lists and print them off, we're going to get, should I label these? I should, shouldn't I? Fine, I'll label them. Card D as list. Items. Keys. Values. Okay. So here's the whole dictionary. Here's the dictionary as a list, just cast straight up as a list. Here's the items. This is pretty interesting. If I cast this dictionary.items as a list, notice I get actually a list of tuples. I know we haven't talked about tuples yet, but you can think about, like I said, you can think about them as immutable lists. Tuples are delimited with parentheses. I know parentheses do a lot of things, but they also do tuples. But it's a list of tuples, two-part tuples. And then if I do keys, notice that's the same thing as just casting the dictionary straight off. And then dot values, that gives me the values. So this is an important thing. These three methods, items, keys, and values, are really important. If you're iterating through a dictionary or if you're checking membership, ask yourself, am I checking membership of the keys, the values? Do I need to iterate through both? I think the safe assumption is if you don't know, if you're iterating, if you know you need to iterate through a dictionary, but you don't know whether you need to iterate through keys or iterate through values, the safe assumption is to just write your loop to just iterate through both. And once you get your program working, just look inside that loop. Did I use one and not the other? If I used both, then I needed to iterate through both. If I used one, if I only used the value, then I can, kind of refactor my code and clean that up. You can always go back and clean up your code. So any questions about this? I see a couple maybe that I've missed, but yeah, go ahead. If anybody's got questions about this, I'll kind of go through what's here. How would you alphabetize the frequency dictionaries keys that you made to see how many times the and the showed up? Alphabetizing would be sorting. We could do sorted. So notice this is actually similar to what I was doing down here. So here's my dictionary. This function returns my dictionary. I do dot items, which gives me both. Oops, I didn't want to do that there. And then I'll just sort it, and that'll give me a list of the sorted items. This will alphabetize them. The thing is, I did dot lower here, so we're not getting a capital the and a lowercase the. And if you do alphabetize these, we'll get capitals, all the capitals first, and then all the lowercases. So you won't get capital T followed immediately by lowercase t. You'll get all the capitals alphabetized, all the lowercases alphabetized. And that's lexicographical order. It follows the ordering of the ASCII characters. ASCII characters are laid out capitals, then lowercases. If you wanted what I think you're talking about, you'd have to write a custom function, which I'm not going to do right now. Can a key be assigned multiple values? Did we already touch on that? Well, in absolute terms, no. A lot of times you can think of a key in a dictionary. I think the person asking this question, I think gave that answer earlier about thinking about it like a variable, right? I think you were the one who gave the answer about thinking about it like reassigning a variable. So, I know it's a little on the nose, but like a lot of times you can think about a dictionary key value pair, or the key, D sub key, is a variable, right? So how would you think about if I asked you the question, can you assign multiple values to a variable? How would you answer that question? You'd probably say, well, no, a variable can have only one value at a time, but you can have that value could be a list. We've also talked about tuples. We've also talked about dictionaries, right? So it could be a collection type that holds multiple values. It's a good question. Cool. assume we're good on that. We just talked about membership. That's convenient. If we check for membership in the dictionary just straight off like this with no method call, we're checking in the keys. Like I said, that's not the behavior I would have chosen for that. I would have just, I think if it were up to me, I would have just said that's an error, and I would have sent a message that said you may want to check keys or values. And the reason for that is I like to be very explicit in my code. It's not that much extra code to just write dot keys parentheses or dot values, right? And it makes it dead clear what you're doing. Now, everybody that, when I say everybody that knows Python, people that, the Python community uses this syntax to check keys in dictionaries. This is formal, this is canonical, that's how everybody does it. You kind of need to understand that that's how that works. For me, when I write my own code, I like to write dot keys because I'm particular like that, and it's my code. So traversing dictionaries, this is just relating to iterating through a dictionary using dot items. If we iterate straight through the dictionary again, it's only going to give us keys back. You kind of see a pattern emerging there probably. Cool, we're going to get into some dictionary methods here. Pop, get, copying a dictionary. We're going to have to save that for next time. But I'm hoping the goal for today, we're about out of time for today, but my goal for today was to lay the foundation and the basic understandings of dictionaries. And on Monday, we're going to go through and cover the rest of this, get a little more into the nitty gritty. Mutability aspects. Well, I guess we got into mutability with assignment and reassignment. Cool. I will wrap up there. Let me just stop the recording and we'll open up for questions.